So hopefully you know what a sample is. You know what a sample is? What is it, Julia?
A group within a population.
Close. So I'll just put the word population first. Something from the population, so it's not a group. A portion of the population. Okay. I guess that's what you meant by group. But in a practical sense, what does a sample mean?
Is it like a randomly selected portion to represent the population?
Still a portion, but what do you mean by portion? Do I use a portion to make inference?
Whoever you're doing a test on, or
Okay, what do I need to do a test? The most important thing in statistics. Probability, okay. It's easy, you're overthinking. You can't do a test, you can't do any analysis unless you have a sample. I agree that it is a part, a group, a portion from the population. Great. That is theoretical. But in practice, what does it mean? If I say I have a sample, what do I have at hand? Okay, I forgot your name.
Levi.
Levi. Data. What does data contain? Do you want to elaborate?
A specific number.
A number, getting there. Just one number or a bunch of numbers?
Well, it has to be within a range
Does it have to be?
for sample size versus population. The sample size is usually small.
Okay, sample size, which would mean, am I going to have a single number or a whole bunch of numbers corresponding to a sample size?
Usually a bunch.
Usually a bunch. It is a bunch. So, data, simple terms, realistically speaking, is simply a set of observations. The word population. Going to combine that with someone else mentioned, randomly selected from the population. So what you're all referring to, which is correct, you remember stuff from 2023, you have a population and you randomly select a sample from that population. That simply is a conceptual realization. But if I want to apply it in real life, realistically, what is a sample? It's just a bunch of observations that I collect. Sample size is denoted by the letter N. It could be 10 observations, 100 observations, 200 observations. These days we have a lot of observations, which present some challenges. You might have heard the word big data thrown around a lot. What we refer to is data that is in the size of gigabytes. To analyze stuff from the human genome, DNA sequences. Each file is about 1.7 gigabytes, 2 gigabytes. So back when these tests were done, sample sizes were relatively small. You know, we didn't have sequencing and technology that we have today. Things have gotten larger. We will start with small sample cases, but eventually I will introduce to some big data scenarios. I believe the book does it. We will see. So are we clear? We're trying to apply stuff. So sample means a set of data points. What do we initially do when we get a sample? Which is why I wrote it as initial steps. What do you do? Let's say you have a table. I give you a table. You have 100 numbers. Let's say those 100 numbers come from a population, we'll start simple, of students. Those 100 numbers, let's say, is their starting salary upon graduation. Good. What would you do?
List them in increasing order.
List them in increasing order. Okay. Any other thoughts? Let me ask the question based on what Omar said. Do I have to put them in increasing order? No, not necessarily. I could just use the data as is. So once you have a sample, don't necessarily have to put it in increasing order. But there are other things that one has to do. Towards. I'll give you a hint. This is what 2023 started with when you first took the course. As we chapter.
Calculate the sample statistics.
Calculate sample statistics. Okay. Enlighten us, Rhonda.
So you would calculate measures of spread and measures of central tendency.
He's using all kinds of fancy words. Okay. Measures of
Spread,
spread.
measures of central tendency.
Okay. Is that it? That's it. I would say there is one more. Clearly make me proud.
Wait, ask the question again.
So once you have a sample, what do? First, calculate sample statistics. And I asked, well, what are they gonna say? Measures of spread, measures of central tendency. It's being very generic. There is another
Z-score.
very good,
Yeah.
but that's a specific case. Generically, it falls under the category measures of.
Data.
You were going in the right direction and then you turned around.
Okay, I'll go back.
I'll give you the answer. Measures of possession.
Oh.
So that should be my initial step. Measures of spread, measures of central tendency, measures of possession. Fancy terms, but what are the statistics that fall under each of those? Mean, median, mode. We don't use mid-range, but there is mid-range. When I get to R, you will see that we typically don't use mid-range. In terms of spread, standard deviation varies, interquartile range. Yes,
Can you move this chair? Thanks.
last one, position. Percentiles. The fancy name for it is actually quantile. So to get an initial idea about the sample, compute a bunch of numbers, measures the spread, center tendency, position. Those are the statistics that fall under each category. Some like to call it sample statistics, some like to call it descriptive statistics. They all mean the same. Are we clear? So step one. All of these are computations, but if you want to present something to someone, what would you rather use? Instead of displaying a bunch of numbers, what would you prefer? Percentile is
A graph of any kind.
a graph of any kind. Graph. So visualization is better. So our objective is to understand or compute these, but I don't have to show all the numbers to someone. I can simply visualize and get an idea as to what these are. Put it as an intermediate step. Visualization. Any graphs that you remember? Scatter plots is one. Good.
Bar.
A bar graph. Okay.
Pie chart?
Pie chart, I'll just put that here. Because they sort of give similar information. Box plot, okay, box plot.
Histogram.
Histogram. Histogram is like the Mona Lisa for a statistician. Boy, it gives you the underlying shape of the entire sample. Shape relates to pretty much everything we do in statistics because it will correspond to what we call a density. So each of these graphs serve their own purpose in a scenario. Bar graph, pie chart, used when data is not numerical. Rather, it is qualitative or categorical. Do we remember what that is? I'll show cases here, but understand me. Is it coming back to you? What is your name? Nikki, when you said pie chart, what did you have in mind? What kind of scenario did you have in mind?
Maybe something where you're comparing like percentage of different categories.
Percentage of different categories. So can you think of an example for those categories? Some realistic examples.
Demographics of the school.
Demographics of school. So if you want to look at demographics, well, perhaps, you pick gender or race. They're not numbers, they are rather categories. A good way to visualize that would be bar graph, pie chart. I'll do this as scatter plot. Why do we need the scatter plot? Or when do we use the scatter plot?
I would just say like when you do like in my example, like a science lab or something like that, you have different data points and you're trying to get a line of best fit.
Line of best fit. So to draw a line, what do you need?
So like the average or like
Okay, I get where you're
maybe
going.
average isn't the right word.
Simpler than that. In order to draw a line, I'm going like this for a reason. So to find the slope, what do you need?
Quantitative data.
Very true.
Points to calculate the slope from.
We need the slope.
A graph point to calculate the slope from.
A graph of points, you said.
Or something like that.
Um,
Wow, so
what is the formula for a slope?
1% plus B.
For slope?
Y2 minus Y1 over X2 minus X1.
Okay, what are x1, y1, x2?
Points.
They are points. So you need two values, x1, y1, x2, y2, and so on. Scatter plot is used when you have bivariate data. So you can write that down, it's going to come later on. One sample problem is univariate. Often the confusion is when we get to two sample problem, one might say, oh, I see the word two, so it has to be bivariate. Not necessarily. So two sample doesn't always mean bivariate. When do we use box plot and histogram? When the data is. Come on, now is your chance.
I just remembered that the box plot was a thing. I didn't remember when to use it.
Like it was a thing just like a minute or two ago. You gave an answer that applies to these two.
Quantitative data.
Quantitative data, so. That table right there, marine sciences, you said. So if you did some sort of a research and you measured stuff, someone said, whales, study of whales, marine mammals. So say you picked some mammal and you're trying to measure their length, for instance. That data that you have is quantitative. Box plot, histogram, both of them are good plots that are used in the sciences. I'll show you how to create them using plot. So key steps, when you have a sample, first thing to do is compute statistics, but somewhere in the middle, it's better to visualize.